All right, looking at our 8.1 mastery learning objective, I can simplify rational expressions by factoring the numerator and denominator to factor out, or to divide out the common factor. Not working. Okay, so our two vocabulary that we're going to look at is what is a rational expression, and then what makes it a simplified rational expression. So a rational expression, hold on. Oh, there we go. Sorry guys. So a rational expression is, right, well the word rational means fraction. Right, so a rational expression is a fraction with a polynomial in the numerator and the denominator. Okay, so basically it's what we had last unit, polynomials, but now they're fractions. Okay. A simplified rational expression is no common factor in the numerator and the denominator. Okay. So basically, and denominator. What we want to do is, when we have a rational expression, we want to completely factor the top, the numerator, and completely factor the denominator. If anything's the same, then we cancel those out, right? We divide them out, and whatever is left is our simplified version. Okay? So looking at some of our examples here, we're first going to start with just just numbers, right? 15 over 21. I want to simplify this. Well, 15 is 3 times 5, and 21 is 3 times 7. All right? They both have a 3, and 3 divided by 3 is just 1. So we are left with 5 over 7. Alright, so looking at letter B, 5 over 5x, right, again, 5 over 5x is the same as 5 over 5 times x. So what happens is 5 divided by 5, those do cancel. But what we have to be very careful of is we cannot have no numerator. So we have to write 1 over x. Have to have a numerator. Okay, so if everything in your numerator cancels out, you're dividing, right? 5 divided by 5 is 1. So there's still a 1 there. And then there's an x in your denominator. Okay? All right, looking at C, 2x times x minus 5 over x minus 5 times x plus 1 times x minus 1. Okay? So this is already all split up for us. Again, all these things are being multiplied. So I can cancel out this x minus 5 and this x minus 5. So I have 2x over x plus 1 times x minus 1. I cannot cancel the x's here. X here is not let's just say its own factor. Right, both of these ones. Is not its own factor, so can't cancel with x in the numerator. Okay, you can only cancel if the factor is exactly the same. X and x plus 1, while they both have x's in them, are not exactly the same. All right, letter D. I have x squared minus 5x minus 6 and x squared minus 1. So for here, my step 1 is going to be factor. The numerator and the denominator. As I factor my numerator, right, I'm adding to negative 5 and I'm multiplying a negative 6. I believe that's negative 6 and positive 1. So I get x minus 6, x plus 1. Okay? That was my numerator. Again, this is going back to all the factoring we did. Now I have this x squared minus 1. Difference of squares. A good thing to look for when you have, right, a subtraction and, right, a squared, something like that. So I take the square root here and the square root here. The square root of x squared is x. The square root of 1 is 1. So I have x plus 1, x minus 1. Okay. So now I have x minus 6, x plus 1, over x plus 1, x minus 1. Okay? So our numerator, we factored it and put it right back in our numerator. Our denominator, we factored it, put it right back in our denominator. These cancel, so I'm left with x minus 6 over x minus 1 is my final answer. Okay, looking at letter E. This isn't a quadratic, so I can't factor it, but I do need to look for a GCF. So both of these have a 3 in them. So I'm going to move that 3 out here, and I'm left with x plus 2. This x plus 2 is not a quadratic, and 1 and 2 do not have common factors, so it's just going to stay exactly how it is. So I have 3 times x plus 2 over x plus 2. These x plus 2 factors are exactly the same. So I'm left with just 3. You don't have to have a denominator. Okay, you do not have to have a denominator, you have to have a numerator. So there's 2 different things with those. Alright, we've written all of our rules now. I don't think there's any other weird little things. We just have to be careful that we are following and paying attention to every type of factoring we've ever seen. And that's what makes this more difficult than it looks right now. There are lots of different things we have to look for. GCF, trinomial factoring, difference of squares, all of these things we've done. We just have to be able to see them. Okay? So that's going to be the most difficult part. So let's look at our numerator first. 3x minus 15. The first thing I'm always going to do is look for a GCF. This does have a GCF. 3 and 15 are both divisible by 3. So the 3 goes on the outside. I have x minus 5. The next thing I look for is what's left. Is it a quadratic, yes or no? This is not a quadratic. There is no x squared. If it's not a quadratic, you are done. There is nothing more you can do. Okay. Does this have a GCF? 1, -2, -15? No. If there's a 1 in there anywhere, you know you're not going to have a GCF. Okay? Next, is it 2 terms or 3 terms? 1, 2, 3 terms. 3 terms means our x factoring. We are adding to -2 and multiplying to -15. Okay. -5 and +3. So that's x minus 5, x plus 3. Something that can help you out to look for is I probably wouldn't give you a problem that doesn't do anything. So it's probably a good thing that you have common factors, because otherwise it's not much of a problem. So we have 3 times x minus 5. That's our top part. And we have x minus 5 and x plus 3. Right? These cancel. And we're left with 3 over x plus 3. Done. Okay, we have a few problems on the next page. Just 2. Alright, looking at G, I have z squared w minus z squared. Both of these things have a z squared in them. Z squared minus z squared. I bring the z squared out. These z squareds cancel out. I'm left with w minus. These z squareds cancel out. It's still 1. I'm going to highlight this. Right? A lot of people just cancel them out and lose them. They just think it's a 0. And it's not a 0. Z squared divided by z squared is 1. So we still need minus 1 there. Okay. Then looking inside here, this is not a quadratic. I am done. There is no squared in my parentheses. Here, I have z cubed minus z cubed w. These both have a z cubed in them. I'm going to take that out. It comes on the outside, and I am left with 1 minus w. So now I have z squared times w minus 1 and z cubed times 1 minus w. Oh, I said we were done with like new weird things. This is one last new weird thing. When you have something like this, where these are almost the same, but flip-flopped, you can't quite cancel them out. Subtraction is not commutative. It is not exactly the same. What you can do is from one of them, and I usually choose the top, the numerator, I'm going to take out a -1. So I'm going to divide both of these by -1. The -1 pops out, just like the z squared pops out, right? W minus 1 is -w. W divided by negative 1 is negative W. A negative divided by a negative is a positive. This has now made these the same. Okay, so if you have flipped subtraction, you have to take the negative 1 out, so then they're the same. That cancels. I have 2 z's here and 3 z's here. I'm going to rewrite this as negative 1 times 2 z's over 3 z's. I have a z here and a z here. I have negative 1 over z. I know my z's look weird. Sorry. Done. Okay, so that was another weird trick we have here. I'm trying to have every problem have a weird trick so that you see all of the tricks. All right, last question, H. 6y cubed minus 9y squared. Well, 6 and 9 have a common, right, can both be divided by 3. Y cubed, y squared. They both have at least 2 y's. This one has more than 2 y's, but you have to have like the smallest number they both have. Okay. So I take the 3y squared on the outside. 6 divided by 3 is 2. Y cubed divided by y squared. I have 3 y's. I take away 2 y's. I'm left with just 1 y. Minus 9 divided by 3 is 3. And my y's are canceled. This is not a quadratic. I do not have to worry about it. My denominator. I have 2y squared plus 5y minus 1. 2, 5, and negative 1 do not have a common factor. I am doing my x. I'm adding to 5. Then I am multiplying to 2 times negative 1, which is negative 2. This question doesn't make sense. Hold on. I think this is supposed to be a 6. Can I change this without too much drama? No, a 3. I'm sorry. Can I change this without too much drama? Okay, so I'm adding to 5 and multiplying to negative 6. I don't know if this is going to do anything. So at least my factoring works, though. I have 6 and negative 1. So then I want to divide, right, since I multiplied by 2, I want to divide by 2. Sorry, I'm trying to think through things here. This equals 3, so I have y plus 3 and 2y minus 1. That didn't do anything. Okay, so my two forms are 3y squared over 2y minus 3 and y plus 3 over 2y minus 1. And this problem actually doesn't do anything. This already is simplified. There's nothing I can cancel. Okay, I said there's going to be a lot of factoring in our unit, right? So look over these and I'll see you guys on Tuesday. Have a good 3-day weekend.